Okay, well, this is a little exercise in the prisoner's dilemma. The prisoner's dilemma is probably the most famous puzzle in the field of game theory. It was invented in 1950 by two scientists at the Rand Corporation. Here, the interests of the players are not in total conflict. In fact, both players could do well by getting the reward for mutual cooperation. In the first one here, you have the prisoner situation where prisoner B rats on prisoner A. Prisoner B gets 0 more years on his sentence, but prisoner A, by staying silent and being turned in, gets three years more. If B stays silent and A testifies, just the reverse happens. But if they both stay silent, then they both have only 1 year to do, and then they get out. And I'll just quickly say, on the right you've got a hawk and a dove, and if they both learn to walk away, they both get 2 offspring. Okay, let's get off of this and get on to the program. This is a very, very simplified version of the prisoner's dilemma. Basically, it's a learning algorithm, and it tries to learn what is the best strategy. And so the seller, if the buyer and the seller both cooperate, they will both end up with full briefcases. But if the seller defects and the buyer cooperates, the seller gets a briefcase, but the buyer is empty. And likewise, if the buyer defects and the seller cooperates, then the buyer ends up with a full briefcase. If they both defect, then they both end up with nothing. So obviously the goal is to learn to cooperate. So let's get it started. What I've done for ease of your vision, first of all, I've made buyer blue and I've made the seller red, and C stands for cooperate and D stands for defect. And to make it even easier, I've put a little asterisk over every time they both cooperate. So you see here they've cooperated 6 times. This is the very first run. So there's 1, 2, 3, 4, 5, 6 times that they've cooperated. Let's run it again. Okay, now we had 6 the first time, but now all these numbers are totals of all the run, and this is run 2. So if we had 6, we must have 12 this time. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There they are. Okay, let's do it again. Run 3. We had 18, and this time it's 28, so we must have 10 this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Indeed we do. And we'll just what happened? In only 4 runs, they all learned to cooperate. Excellent. Let's see what happens with the 5th run. Same thing. Same thing. Same thing. 8th run. 9th run. 10th run. Well, I guess they're going to cooperate for good. They all have C's, and thank you for watching.